Okay, let's look at an example now. For example, you are given this sequence of numbers 2, 4, 6, 8, 10 and so on, and you are asked to determine whether this is a GP or whether this is an AP or is basically just a sequence. Okay, in GP, what we do to find out about the common ratio is roughly the same as how we find a common difference in AP. So we'll use a later term to divide by the previous term. Okay, in AP we use a later term to subtract the previous term. Okay, and in GP we basically use a later term to divide by the earlier term. So let's try. For example, I take let's say I take term 2 divided by term 1. Okay, so I have 4 divided by 2. Okay, that gives me 2. Okay, and I take term 3 divided by term 2. So term 3 divided by term 2. Okay, that will give me 6 divided by 4. 6 divided by 4, and that gives me 1.5. Okay, and you can see that it's very clear that these two ratios are different. Okay, therefore common ratio doesn't exist, and this sequence given to us is not a GP. Okay, now let's take a look at another sequence and see whether this is a GP. So same thing, we use the later term to divide by the earlier term. So term 2 divided by term 1. Okay, I have 6 divided by 3. Okay, this gives me 2, and I will use term 3 divided by term 2. Term 3 divided by term 2. Okay, so that will be 12 divided by 6. This also gives me 2. Okay, as you can see, our ratio for both cases equals to 2. So we can say that the common ratio exists, and this sequence given to us is actually a GP. Please take note that it is not required that you always make use of term 2, term 1 and term 3 to compute the common ratio. If you want, you can also use the term 5 divided by term 4, compare it versus term 3 divided by term 2. That will still give you the same ratio if the sequence is a GP.